Hello, everyone. Welcome back to the Mathematician's Den. This is the Herm Dog, and let's talk about today trig functions, but let's apply the chain rule. In other words, what would happen if you're deciding to take the derivative of sine of a function or cosine of a function? Well, you apply the chain rule. So the derivative of sine is cosine of the function, but you multiply by the derivative of the function. The same is true for all of these other trig functions. If you take the derivative of cosine, the derivative is negative sine of your function, multiply by the derivative of your function. On every single problem, if there is a function inside your trig function, multiply by the derivative of that function up front. So to give you an example of what I'm talking about, let's do this first problem. What is the derivative of sine? Well, it is cosine. Cosine in this case of x squared, but what is the derivative of x squared? You're going to multiply by 2x. Same thing for the problem right below it. What is the derivative of cosine? Well, first of all, this is cosine of x to the 1/2. So let's keep that in mind when I'm doing the derivative of this function. F prime of x would be, the derivative of cosine would be negative sine of radical x. But the derivative of x to the 1/2 is 1/2 x to the negative 1/2. So this would be my derivative of this function. Let's move down and talk about tangent. This function is tangent of x to the negative 3. So when I'm taking the derivative of this particular function, I want to make sure that I take the derivative of that out front. The derivative of tangent is secant squared of 1 over x cubed, but the derivative of x to the negative 3 is negative 3 x to the negative 4, which would put x to the 4th on the bottom. There's my derivative on this one. Let's keep going with some of these other trig functions. Let's talk about secant here. The derivative of secant is secant of whatever, tangent of whatever. But what's the derivative of the inside function? The derivative of the inside function is negative 7. Just because we wrote this twice doesn't mean I take the derivative twice. The original function has 1 negative 7x inside. I multiply by its derivative out front. Here is the derivative of secant of negative 7x. Let's do the same thing with this next function. What is the derivative of cosecant? It is negative. Cosecant of this, cotangent of this. What is the derivative of that inside function? Using the power rule, it is 10x. There is the derivative of that cosecant function. And the cotangent function right below it, if I rewrite that, that's going to be cotangent of 5x to the negative 2. So how do I take the derivative of that particular function? Well, the derivative of that particular function, f prime of x, would be negative cosecant squared of 5 over x squared. But what's the derivative of this inside function? It would be negative 10 x to the negative 3. Now take a look at that. If I multiply by that out front, it would cancel this negative and make it 10 over x cubed. There was a negative from the trig function. There was a negative from the power rule. Those negatives canceled and made it a positive function multiplied out front. Now this next one, I like to call it a triple function chain rule. Why? Because really what we've got here, we've got 3 functions. The outside function is the 5th power. That would be like your f of x. The next function going inward would be sine of x. So that would be like your g of x. And then the very inside function is going to be x cubed. That would be like your h of x. So this is like a triple function chain rule. Now, when you do derivatives, you start outside in. So we're going to start out with f of x. What is f prime of something? Well, in this case, it would be cosine, or sorry, I'll back that up. I didn't follow my own rule there. It's the 5th power, so it'd be 5 times something to the 4th. Well, that something is the sine of x to the third. We don't change that. Now I'm going to multiply by, so in other words, I don't change the g of h of x on the inside. Now I'm going to multiply by g of x and multiply by its derivative. The derivative of sine is cosine, in this case, of x cubed. I did not change h of x. But what I do have to do is multiply by h prime when I'm done. So I got to multiply by 3x squared. So you notice I took the derivative of f in the dark color, the black. Then I took the derivative of the red for g. And then I took the derivative for h in the green. All while in the previous step, I left the inside function alone. So I took the derivative of f of x, left the inside alone. Took the derivative of g of x, left the inside alone. And then I multiplied by the derivative of h of x. And if I simplify all of this, I'm going to get 15x squared. I've got, cosine of x cubed in there. And I've got sine to the fourth of x cubed in there as well. There is my triple function chain rule. And yes, you may have to do that. It's the same thing as you move on down the page here. That sine to the fifth x, I think you guys should all know this, that is sine of x raised to the fifth. So how would I take the derivative? Well, I'd do the outside function first. I would do the power function first, 5 times something to the fourth. What is that something on the inside? It's sine of x. But then you have to multiply by the derivative of sine, which is cosine of x. So my derivative is 5 sine to the fourth x times cosine of x. That is my derivative for this function. Now remember, in order to find the slope of a tangent line, what you have to do is you have to take this number, pi over 3, and we're going to plug it into our derivative, so it's going to be 5. What is sine of pi over 3? Well, that's radical 3 over 2 from the unit circle. What's cosine of pi over 3? Well, cosine of pi over 3 is 1/2. If I multiply this out, radical 3 to the fourth is 9. 9 times 5 is 45. And on the bottom, I'd get 2 to the fourth times 2, which is 32. That is the slope of my tangent line. How do I write my tangent line? Well, my tangent line is y minus y sub 1 equals my slope times x minus x sub 1. Well, I know my slope. My slope is 45 over 32. I know my x value. My x value is pi over 3, so I'm going to plug that in for x sub 1. But what am I putting for y sub 1? Well, the original function is f of x equals sine of x to the fifth power. And we have to find this value at pi over 3. Well, what did we say sine of pi over 3 was? It was radical 3 over 2. And if I raise that to the fifth power, I'm going to get basically 9 radical 3 all over 2 to the fifth, which is 32. So I'd have to put that number right here. To write a tangent line, you need an x value. Plug it into the original function, you can find the y value for your coordinate. Plug it into the derivative, okay, and you can find your slope. And we did a tangent line problem here with trig. If you like this video, please hit the like button. Please feel free to subscribe to my channel. I'll be posting more videos as time goes by.